Hi, Algebra 2. Here we are in Chapter 12. We're at the end, our final section. It's 12.9, sampling error. When we talk about polls in any circumstance or situation, when we're checking out or trying to figure out people's opinions, it's impossible to ask everyone, right? So what we do is we would find a sample size, like a group of people that represents the larger population. For instance, if I wanted to find out the opinion of Americans all over the United States of America, I'd want to collect samples of people from every state or at least all over and from different regions so I can get an idea of how Americans all over are thinking about a particular thing. And then not just a sample that includes all Americans, but I'd probably like to get a variety of ages because certain ages of people in America might think a particular way. And so those are some of the things that we think about when we want an unbiased sample. So for instance, if we were thinking about the recent election and we were to consider, okay, who's going to win? And a lot of polls had one candidate winning over another candidate. But if I were to poll only in a particular section of the United States, you guys get the idea. That wouldn't be a great sample because we know that opinions vary in different regions and with different ages and with different ethnicities and so forth and so on. So an unbiased sample would be a truly random sample. Let me get this picture out of the way. So like a truly random subset of the population would make for a less biased sample. And we'll talk about that in a moment. Um, and the margin of sampling error. So like if I were to choose a really great random group of people and they were five, and I wanted to choose five people across the United States to figure out what the general opinion of an American is, you guys already know that that's not going to be really good. The sample is better and more accurate representation of the situation that we're dealing with as long as it's large enough, right? So when you have a large sample, you have a smaller margin of error. And so we have a formula that we're going to use. This thing here looks imposing, but we'll manage it. That's going to help us calculate the margin of error. And you'll recall margin of error when you might see 53% of Americans feel whatever, whatever, plus or minus a margin of error of 3%. So we could be above or below 3%. We expect most of the people to fall within that category who chose that particular opinion. A real quick story about sample bias sample size or bias sample groups. I remember hearing about this when I was in college, when I was taking like a political theory class or something. And basically, this presidential election between Alfred Landon and Franklin Delano Roosevelt was called poorly by the Literary Digest poll, and they had really sampled a lot of voters. I think I saw somewhere in this article 2.4 million people were sampled, as opposed to the Gallup poll, which sampled less but was more accurate. Here it is. The polls were conducted, had a sample size of 2.4 million people, which is really good. Like the larger the better. And then the George Gallup was able to predict the result for Roosevelt with only 50,000 people. And the question is why? Because I just said, you get a better sample when it's larger, but you need to make sure that your larger sample is a random sample. And so the Literary Digest method for choosing its samples was as follows. It was based on telephone directory in the United States, list of magazine subscribers, rosters of clubs and associations, and other sources. And a mailing list of 10 million names were created. Every name on the list was mailed a mock ballot and asked to return the marked ballot to the magazine. So they ended up getting 2.4 million people to respond, which is awesome. But the problem was not that they didn't have enough people. It was that they chose people who were in the telephone directory. They chose people who were obtaining magazines, which, if you think about it, would only be a fraction of the population. The upper and middle class portion of the population as opposed to a more diverse background or a more diverse financial profile of the people in America. And therefore, the Gallup poll did not have that kind of a bias and ask people from a lot of different demographics as opposed to sticking to upper and middle class. Kind of interesting. Okay, let's go on to our examples. Biased and unbiased samples state whether each method would produce a random sample and explain. So, asking every 10th person coming out of a health club how many times a week they exercise to determine how often people in the city exercise. Okay, hopefully, you all can see that this is a bit biased, right? This is a bit biased. This would not result in a random sample because the people surveyed would probably exercise more than the average person. Let's try one more. Surveying people going into an Italian restaurant to find out people's favorite type of food. I think we see the error. And this would probably not result in a random sample because the people surveyed would probably be more likely than others to prefer, even sometimes, Italian food. So we want to make sure that we don't make when we are sampling people, we want to make sure we don't make obvious mistakes like this, right? So now we get to the idea of margin of sampling error. So what we have gathered, and I really, sometimes this is my bias against this particular branch of mathematics because we have to kind of accept some formulas that we haven't developed. We need a little bit higher mathematics to develop some of these formulas. But I'm asking you to accept if the percent of people in a sample responding to a certain way is P and the size of the sample is N, then 95% of the time, the percent of the population responding in that same way will be between P minus the the margin of error and P plus the margin of error, where the margin of error is this. So it's going to be 2 times the square root of the product of P times 1 minus P divided by N. And if you remember anything, you know that the denominator of a fraction will decide on or determine how large the number is, right? So the bigger this denominator is, the smaller the margin of error. And in that way, since N is the sample, the total sample size, we know that the greater the sample size, the smaller the margin of error we will have. Let's practice using this formula. So here we go. Find the margin of error. In a survey of 1,000 randomly selected adults, 37% answered yes to a particular question. What is the margin of error? For convenience, we rewrite the formula here for margin of error, and let's go ahead and begin to calculate. So what we'll do is we will use the percentages. This is going to be the number of people, the percentage of people. We're going to plug that in here, and then we're going to put the total number of people that were randomly selected right in there for N. So what we end up with is 2 times the square root of 0.37. Look how I'm putting that percentage in as a decimal. Times 1 minus 0.37, all of that over N, which is 1,000. And so with a little bit of calculator help, our calculator says this, and this lets us know that we have plus or minus 3% margin of error. So with this margin of error, what this means is that there is a 95% chance that the people who are in this sampled population would say yes, would be between 34%, that's the minus the 3, and 40% of the people, 95% of the population at large would have a yes answer of between 34 or 40%. I know that sounds a little crazy. Just pause me and think about it. In a recent Gallup poll, we have that 25% of the people surveyed said that they smoked cigarettes in the past week. The margin of error was 3%. Well, what does that 3% mean? Well, that tells us, right, and we know this from the last problem we just did, that tells us that like from 22% of the population to about 28% of the population, we know that within these two amounts of the population, that 95% of the people would say that they had the same experience of, in this case, smoked a cigarette within the past week. So as the textbook has it, that 3% means that the probability is 95% that the percent of people in the population who had smoked cigarettes in the past week is somewhere between 22% and 28%. I hope that makes sense. I feel like all these percents seem a little bit confusing, but it's 95% true that this is happening between this particular two percentages. Oh, my goodness. All right, let's go ahead. How many people were surveyed? This we can find out. We're going to have to pull up that equation we were using before, the formula. Now, after we have our formula, we're going to plug in the information we know. So the 2 is there. We don't know the population, but we do know that we're dealing with 25%, right? So we've got 0.25 times 1 minus 0.25 over n. And so we've got to do a little bit of math to calculating this. Oh, and the margin of error was 3%. So we ended up with 0.03. So that should be enough to help us out. We need to calculate our answer. So I'd first divide both sides by 2 to get the 2 away. Remember, we're trying to isolate n, then maybe square both sides to get the square root away off the right side of the equation. And then so when I square it, that's gone. And then I'm going to want to solve for n. So I can do a couple of things. I can cross multiply. I can use the reciprocal theorem, which means if I take the reciprocal of one side and the reciprocal of the other, let's multiply the numerator there. And finally, with some algebraic manipulation, we will get this equation if we, do cross multiplication and divide, or simply recognize that we can literally kind of switch the places with this. We saw this happening a lot when we were doing our trig identities and trying to figure out doing a right triangle trig. So finally, we're going to get n is equal to 833.3 repeating people. So we can say that the number of people surveyed was about 833. All right. So a couple things that you want to remember from this section is that really we're just dealing with unbiased samples, being able to truly determine if we have a randomized section, and using that formula for margin of sampling error or margin of error. Look, guys, I hope that everything made a certain level of sense. Let me know. I look forward to talking to you soon. Take care. Bye-bye.